The Gallup organization surveyed 1,100 adult Americans on May the 6th through the 9th, 2002, and conducted an independent survey of 1,100 adult Americans on May 2 to 7, 2013. So these are definitely the N1 and the N2. In both surveys, Gallup asked the following. Right now, do you think the state of moral values in the country as a whole is getting better or getting worse? On May 2 to 7, 793 of the 1,100 surveyed responded that the state of moral values is getting worse. So both are 1,100. For the second one, X sub 2 is 793. And on the first one, 737, X sub 1, 737 said that the moral values are getting worse. Construct and interpret a 90% confidence interval of the difference between the two population proportions. Okay, so this time we're asked to create a 90% again. They chose 90%. Everything is there for us. Just make sure that you select the correct item, two proportions Z interval. And X1, 737, N1, 1,100, 793 for X2, and 1,100. And again, I want to calculate. Let's see what I did. 737. Oh, you didn't take that for some reason. Okay, I'm checking 737, 793. Yes, yes, yes. Calculate. Okay, so look what happens here. Negative 0.0831, comma, negative 0.0187. So this is the 95% confidence interval for P1 minus P2. What is our conclusion? Can anyone draw a conclusion for us? Which one is bigger? So on the real line, we have 0 here, and the interval is somewhere here, between negative 0.08 and negative 0.01, 0.02 if you want. So then, knowing that, which one do you think from this particular sample, which one is bigger? Is it P1 bigger or is it P2 bigger?
The negative 0.01.
Which of these two? Is it P1 or is it P2?
P2.
Of course. So P2 is bigger. How do I know? Because the result is consistently negative. So P2 must be bigger because this number minus this number is always a negative answer, at least coming from the sample. So we can conclude for sure that they are not equal. But if I go back for a second to what I said here I cannot conclude that they are not equal. Here I can conclude that they are not equal. Consistently P1 greater than P2. Here I can say they are not equal according to this sample. Consistently P2 is bigger than P1. But if 0 is in the interval, I could say I don't know. I don't know. Okay, the last item before we start working on our problems in MyLabs Plus is again how to determine the sample size. Okay, these are formulas, two different formulas when we are given the margin of error. So the margin of error must be given to us, whatever it is, but it has to be given. So this is E in both. like before, every time we try to determine or we wanted to determine the sample size, the margin of error was given to us. Alpha has to be given to us because we have to determine the z alpha over 2 based on alpha. And then we have two options. In certain situations, a study was conducted prior to our study. So we do have the information P1 hat, P hat sub 1, P hat sub 2, we have that. In a study that we do not have, it's our study is the first on the planet. Nobody else did our study or a similar study. So then we will have to conclude that all this is 0.5. But z alpha over 2, z sub alpha over 2 over e squared, these are the same. But all this calculation is not given to us. We don't have P1 hat and P2 hat from a previous study because we want to conduct a study that nobody has conducted before. In that case, we have to use 0.5. And then we can go back and adjust and change that after we conduct our first sample. Okay, so let's see how we work this out. All these formulas will be given to you. No one is asking you to memorize any of these, of course. So a nutritionist wants to estimate the difference between the proportion of males and females who consume the USDA's recommended daily intake of calcium. Perfect. What sample size should be obtained if she wants the estimate to be within 3 percentage points? Stop. I'll take notes. E equals 3 percentage points, which means this. Then points with 95% confidence. Which means that alpha equals 0.05. Where am I? Assuming that she uses the results, so the results are given to us from 1994-1996 diet study survey, according to which, so males is the first, so we have P1 hat 0.511. And P2 hat 0.752 of females consume the USDA's recommended daily intake of calcium. Okay, so then in order to determine N, which will be again the same thing with N1, I have the formula here. N will be the same with N1, the same with N2. And this will be P1 hat 0.511 parentheses 1 minus 0.511 and then plus 0.752 1 minus 0.752 and multiplied by the square z alpha over 2, in a minute we'll determine that, over e. We should know those numbers by heart by now, but we don't have to. Okay, so we're talking about 95%. So this is the 95%, which means that this turns out to be a total of 5%, but it has to be split in two tails. So this is 0.025 and 0.025. I have to determine the z alpha over 2. This will be z, this is negative z alpha over 2, sub alpha over 2, and z alpha sub alpha over 2. So we go to an inv norm. So go to distributions, inv norm. Let's say I want to determine if they are the same, they will be symmetric. One positive, one negative. It doesn't matter which one I find. Even if I put the negative in here, I will have to square it. It's not going to make any difference, but I will not put the negative. So inv norm, area starts It's 0.025. Of course, the z distribution has mean 0 and standard deviation 1. Yes, the tail is left. Yes, and 1.96. So this is negative 1.96, and of course this is 1.96. We are going to put 1.96 in the calculator. Ready? Careful, careful, careful how you put in all this. So we need a second set of parentheses in the calculator. I don't have brackets in the calculator, so I have an outside parentheses and all this, and then parentheses squared 1.96 over 0.03. Ready? Left parenthesis 0.511. Another parenthesis 1 minus 0.511. Close the parenthesis plus 0.752. Open another set 1 minus 0.752. Close and close the other one. And now parentheses 1.96 divided by 0.03, and don't forget to square that. And I press enter. And I got 1862.6. I have to always, no matter what, I have to always round up to the next integer. Even if I have 1862.1, I would have to say or write 1863. So N1 equals N2, 1863 male and respectively female to be tested or asked about their diet. Second part of the question, where's my second part of the question? Here. What sample size should be obtained if she wants the estimate to be within 3 percentage points? Same thing, 95% yes, assuming that she does not use any prior estimates. Maybe the study wasn't conducted, or she simply doesn't want to use prior estimates or information or study or data. Fine. In that case, we have N equals N1 equals N2, and this is much easier. It's still our 1.96, that doesn't change, 0.03. That is so much easier. So 0.5 and 1.96 divided by 0.03, and we have to square that, and that's the answer. And we got 2.2134.2. It doesn't matter. I have to write that N1 equals N2, 2135. Randomly selected males and same number, randomly selected females. Any questions for me? I'm sorry?
Can you do this in step?
For the sample size